Well, now that we are done with inheritance, we are going to start this exciting chapter called polymorphism. Now, polymorphism is one of the most important chapters of any object-oriented programming. Now, if you recall our early days, in the first few classes, we discussed about the 4 different properties of object-oriented programming, and polymorphism was one of them. So can we just go back and recall what were the 4 properties? Okay, the first property that we discussed was abstraction. The second was encapsulation. The third was inheritance. And the fourth was polymorphism. So, welcome to the class and hope we enjoy this new chapter of polymorphism. It's very important from your placement perspective and also to understand why exactly object-oriented programming is so powerful. So, let's begin. Now, before we start polymorphism, we have to understand what exactly is binding. Now, this is a very important property that actually will help us understand polymorphism better. Now, I remember teaching you exactly what is binding in the class. Now, we're going to do a small recap of the same. I'm sure you must have all forgotten. Right, so let me just briefly go through what exactly are we going to cover in this chapter. So first, I will introduce you to static and dynamic binding. We will talk about the dynamic memory allocation after that. Now, you all must be aware of dynamic memory allocation because you must have done it in C. Now, in C, if you remember, there are methods by which you can dynamically allocate memory, calloc and malloc. And now, when you're talking about the dynamic memory allocation, we also need to look at how the memory is organized. And again, I have covered this in the class during the first few lessons. However, I will revisit and go through the different structures in which memory is organized. After that, we're going to talk about the base and derived class pointers. Now, this is where the properties of polymorphism would begin. And the most important concept, virtual functions. Virtual functions will again define exactly how polymorphism is implemented in C++. Pure virtual function is basically nothing but an abstract class that you call it in Java. So when you talk about Java, we talk about abstract class and abstract methods. The same in C++ is implemented by using pure virtual function. And then we talk about an abstract class and the concrete class. So this overall sums up the polymorphism. Now, before we talk into the implementation of polymorphism, it's also important to understand the whole concept as to why polymorphism is important and how you can apply it in your real-life programming, real-life applications. Now, while we are doing this chapter, I will touch upon that aspect as well and give you an analogy with an example of how polymorphism is important and how it can be compared and it can be used to solve real-life problems. So, let's begin. Okay, so what exactly is binding? Now, I have discussed binding in the class, but I'm just going to tell again. Now, when you have a function and the function consists of different parts, like one is the function body, that's where the entire logic for that function is written, and the second part is where the function is being called. Now, the function body and the function call are written separately and they are also stored separately in your program. So the entire code or the instructions of your program are stored in a separate part of the memory called as the text segment or the code segment. Now, when you look at the text segment, the function, the body of the function is stored in a different memory location, whereas your function call is stored in a different memory location. Now, these two need to be bound to each other. That means if you are invoking a function call, then the function call needs to go to the place where the function body is located. Now, this binding of the function call to the function body is called as a simple binding. Now, what is the difference between a static binding and a dynamic binding? Now, static binding is when the compiler decides where exactly the function body is, and a function call is bound to the function body during compile time. So basically, the compiler is responsible for making that connection of the function call to the function body. Now, we have already done a lot of examples of function overloading, and recently we've also studied operator overloading. Now, function overloading and operator overloading are examples of static binding. Now, static binding gives rise to polymorphism, but of a different kind. It is called as static polymorphism. When we talk about polymorphism in object-oriented programming, our focus is not on static binding, but on dynamic binding, which also gives rise to the dynamic polymorphism. So in your placement exam, if they ask you, do you know object-oriented programming? Can you give me an example of polymorphism in object-oriented programming? Then please do not give an example from static binding, because what they are trying to ask you is, do you know dynamic polymorphism, and do you know how dynamic polymorphism can be achieved in object-oriented programming? Right. Now, what exactly is dynamic binding? In a dynamic binding, the compiler has not much of a role, and although the compiler has a background role in deciding the function call, however, the function call happens at runtime. Now, at the runtime, the compiler is not present. So function call is not decided at compile time. However, the compiler has to play a role in giving, and implementing the virtual functions, which is an example of dynamic binding. So with this concept of static binding and dynamic binding, and how the function call is decided at compile time or the runtime, we move ahead and see the different forms of polymorphism. Now, we know polymorphism means multi, and morphism means forms, so multiple forms. Now, there are two kinds of polymorphism. We just referred to that, and that is runtime and compile time. One is the runtime polymorphism is also called as the dynamic polymorphism, and the compile time polymorphism is called as what? Static polymorphism. All right. Now, examples for runtime virtual function, and examples for compile time function overloading and operator overloading. So this is all very clear. Now, before we move on to the actual concept of polymorphism, it's very important to understand how the functions are called, how the base class functions and the derived class functions are called, and how they differ with a pointer variable and how they differ with a normal object. So let's look at a small example. Now, I'm covering these examples in the initial stages of this chapter so that you can relate to it and see how exactly polymorphism changes the property, and how polymorphism brings the difference in the way the code functions later on. Okay, let's look at this simple program. Now, if you look at this program, we have a class A and another class B. Now, class B is inheriting from class A. So it's all very simple. However, we have a member function called as display. Now, this display is the same member function is declared twice, one in the base class, one in the derived class. Now, let's look at the main method and see how the behavior of this program works when we have the same member function, the same member function with the same name in the base class and the derived class. So it's very simple. You create an object of the derived class here, and you call b.display. Now, can you tell me which display is going to be triggered? Now, before we answer this question, you know that since class B has derived from class A, all the attributes and all the members of class A is available to class B. So class B has one version of display from the base class and the other version of display from the derived class, which is its own. So if you look at this program and you call b.display, so what's going to happen is you are going to have b is equal to 20. So for the first line of code, the b.display will actually invoke the display of the derived class, which is very simple. So 20 will get printed. Now if you want to invoke the display of the base class, then you need to use the scope resolution operator and invoke the display of the base class. Now this is more or less simple. Now let's go to another program and see how, when you use a pointer variable, how the property changes. Now if you look at this program, we have same classes with display in both the classes, base class and derived class. But what we have done here is we have created a pointer of the base class. Now when we point to an object of the base class and invoke the display method, now you know that when you are talking about a pointer, we cannot use the dot operator. We have to use this arrow in order to access the members. So when you're taking a pointer of the base class and pointing to the object of the base class, and when you invoke the member function, in this case the member function of A is going to get invoked. So P is pointing to the object of A, and P, when you invoke display, it's going to invoke the display of A. Now what we do here is we change this pointer and we point this P to the object of B, and then we invoke the display. Now can you tell me what will happen here? What should happen is basically you should get the display of B. However, that doesn't happen. Now what happens is, when you have a pointer of a base class and when you're pointing to either the base class object or to the derived class object, no matter what, when you invoke a function, it will always invoke the function of the base class. That means the display of the base class will be replaced, or in fact will replace the display of the derived class. Now this is an important property that you must all remember. So if you declare a pointer of the base class and if you're pointing to an object of the derived class, the derived class, the base class function will always replace the derived class function. That means no matter what, the base class pointer will override the derived class functions. Now this is an important concept that you must all remember. So with this concept, we are going to go ahead and see how the virtual function works. Now our objective in polymorphism is to ensure that when you are pointing to a base class object, the base class function should get invoked, and when you are pointing to the derived class function should get invoked. Now if we can achieve this, then we have done polymorphism. Now what is the importance of this? We will refer it to another lecture, and where I will discuss you the different ways in which polymorphism can be used. But for now, just remember this important property, that the base class display will replace the display of the derived class if you are using a base class pointer. So we're going to continue with this chapter again in the next lecture, but for now this is an important concept that you must remember. So see you later. Bye bye.